Okay, so you've managed to run Balmorel and get an optimal solution, as we see down here, which means that we'll have the two output files generated. So the two files will be found in the base model folders of your Balmorel model, and they are all end of model GDX and main results GDX. So you can open them by double clicking, but I prefer not to do that. As you can see, that we'll get a new project opened. So I'll usually drag them to the project folder, so it's more easy to inspect. So the all end of model GDX file includes every single parameter, internal parameter, and variables in the Balmorel model. So you can use that for validation typically. Let's say that you did some change on electricity demand. You'll be able to inspect here which change you made. Let's say you did in 2050 for DK1, and for a specific user you'll be able to see if the number that you input is actually inputted correctly. So it can be used for validation. The main results GDX is meant to be an easy overview of the primary results from Balmorel. So in this GDX file you'll have post-processed variable results that are in an easier format simply. So if you're here in GAM Studio, you'll be able to see an explanation, an explanatory text for each. So let's say you ran the Balmorel model twice because you had some sensitivity that you wanted to inspect, and of course you remembered to change the name of main results and all end of model so that it wasn't replaced or overwritten by the new RAN that you made. So we have 4 results here that we can try to inspect. The simplest way to inspect these results would be just going into GAM Studio and looking at the numbers. In the symbols panel here, you'll be able to filter away the symbols so that you can easily find them. That's maybe more relevant if you're looking for a specific parameter or variable in the all end of model file. So for example, the generation of electricity, VGET variable. But let's focus on main results for now. So when you select a symbol here, of course you'll have the view of the values in the right pane, and here you can do filtering to get the whatever you want. For example, filtering on years, maybe a region, and then you'll have your inspected values ready here. Then you can easily compare with another file if there's a specific value that you wanted to observe a change in. So here we see the generation capital costs are around 1,000. In the other scenario, it's 1,300. You'll probably want to use other softwares to inspect the results and treat them and make plots and so on. So of course the most common way to do this would be to look at an Excel sheet. One way to do this is by the export button up here, where you're able to select the symbols that you want to export into a specific Excel file. This will be outputted in the model folder, looking like this. So here we exported the objective function and the production variable. In my opinion, this doesn't look so good. So what I prefer to do is copy pasting to Excel. Let's say we want to look at the production. Then I will simply go to the production here, Control A, Control C, and then copy it down 1 row and 1 column down. Here, press Alt A E, and then select comma, and now we have rows, columns of data. So the reason I copy pasted it over here is because I want to create a scenario column. So we have a scenario column here. We have the year, country, region, area, technology, fuel, commodity, and then we have like an aggregated technology column. We'll have a unit here and we'll have a value here. So I'll go ahead and call this scenario 1. You can use control, arrow down to the bottom of the copy paste that you made, and then control shift to select all of them up to the scenario name that you chose, and then control D. Then you'll have a nice template for looking and comparing two scenarios. So I did the same thing here. Control down and then copy pasting here, and this would be scenario 2. This is a quick way to inspect and compare scenarios. A slightly more systematic way of inspecting your results is to convert them to CSV files. In that way, you'll be able to use whatever software that can read CSVs to more systematically plot figures and such and compare scenarios. So we have a tool for that. It was in the auxils folder and it's called create CSV. So as you can see, this create CSV file will take some input name and a scenario name, read that GDX file in the input folder, and output a CSV for every symbol. So you can see here, this is the symbol corresponding to the main results symbols. So in this case, it's taking the storage capacities of a scenario from the input folder and outputting a CSV for that file. Let's try it out. We need to copy paste. So I'm just control C'ing to the input folder, control V. Now I'll write the correct name, the correct output name, or whatever I want to call it. And this actually won't work. So I'll delete up till here and make that. So now it understands that we're in this folder. In this case, this is where the working directory of the create CSV GAMS file is. So it'll be able to understand that we need to go into the input folder from here. Do the same thing for the output folder. You can also write the entire path, but this should work in general. So let's try and run it. There we go. It's a lot of results, so it might take some time, but we could check the outputs and see, yes, in fact, we are generating CSV files for every of a specified symbol. If you just want a specific file, you can comment out the remaining. Now you'll just get the hydrogen transmission economic results. And from here, I will expect that you have your own preferred tool to analyze CSV files. For the most systematic approach, at least if you're a Python user, you can try to install the Python API in this link where GAMS describes how to install it, which will make it possible for you to just directly load a GDX file from Python. So you can take this script as an example where I input the path and select the scenario. Then I have this function that changes it to a pandas data frame, and then I can load it here. So then you see we get the GDX results directly into Python. Finally, I want to give some tips on how you could process your data into some figures that are easy to analyze. In principle, it can be done in any tool. And I think a very useful method is using the pivot tables. So let's say that we had our two scenarios here with the objective function, and we were interested in comparing the objective function of these two scenarios. I would Control A, press Alt, N, and then S, set, and press Enter. Then I would place this pivot chart over here. And now we've generated a pivot table from all of the data. This is an easy way to inspect your results because you're able to put different parameters in rows and columns. So you'll put the value in the values. I put the scenarios on the axis, and already you see that it starts plotting the objective function value as a function of scenario here. So actually we ran several years in this scenario, so it doesn't make any sense until we start adding the years. And then you could furthermore add the, I've called it G, let's call it the variable. We could refresh. There we go. I'm just going to put the variable here. And now we start seeing all of the variables in all of the years, in all of the scenarios. This is still a bit hard to analyze for me. So I want to right click and change this chart type to a stacked chart type. Now it's more easy to compare the two scenarios. You can hover across each of the bars to see the individual values, or you can expect the table over here that's automatically created. But actually still, it's hard to see any differences between the two scenarios. So what you can do is that you can go to sum of value field settings, show value as difference from. Either absolute difference or percentage relative difference. Let's look at the relative difference from between each year from the first scenario to the second scenario. So we select the scenario field as our difference parameter, and then select SC1. And now we can see that there are some differences in columns that make up the objective function. Okay, now let's say you wanted to inspect a certain time series. Then it gets a bit harder to do that comparison across scenarios. Of course you can do that, but this was with a relatively high temporal resolution. You can see we have a lot of hours, maybe actually all of them. So the data output is pretty large. This is where Excel might be beginning to become a complicated issue. So generally when we inspect time series, we might want to convert it to CSV and then process it with another tool. But in this case, it's possible because I just want to look at one scenario and maybe even 1 year. So I'll select all, Alt, N, S set, and create this pivot chart again in the same sheet, if that's what you prefer. There we go. It took a bit longer because we have a lot of data here. So now I'm interested in looking at the production of electricity. So what I did here was I still took the value down to values, but then I took the commodity down to filter, and then I press over here to select that I only want to look at the electricity commodity. You can select multiple items by pressing this, but for now we're only interested in electricity. So okay. Now I only want to look at one scenario also, so I filter this as well. In this case we only have the SC1 scenario. I only want to look at 1 year. So I select 2050 as well. And then on the x-axis I want the hourly resolution. So we'll have the weeks, and we'll have time. Now we're starting to see the time series as it actually is. And then we could create this as a function of fuels on the columns. So right now this doesn't make sense. So I want to change the chart type to an area chart that is stacked. That is my preferred way to look at these production profiles. And then we can start analyzing. So in this case we have a lot of wind and solar and water. So actually we're looking at several regions right now, so we could further, we're looking at the total system, so we could further scale down and maybe just look at DK1. And there we go. Now we're only looking at DK1 for scenario 1 in 2050 for the production of electricity. Finally, I want to show you how to plot the transmission capacities, because if you are unknowingly just plotting with regards to exporting or importing regions, you will probably count twice. This is due to the fact that we sum capacities in both directions. So what we want to do is, again, I'm going to do the pivot table by Control A, Alt, N, S set, enter, and then place it here. So for this purpose, I'm gonna look at different scenarios, and then I'll take the exporting regions below the importing regions, or vice versa. It doesn't really matter. Now we have several years here, so I'm just gonna pick 1 year and then look at the values. So this is a large system, so this is nonsensical to look at. So I'm just gonna show results only for Denmark and Norway. Maybe we could even put it over in the legends so that we can separate the countries. Great. So now we can compare the scenarios, and we could look at each exporting region's capacity to an importing region without counting twice. For example, you can see that the capacity from DK1 to NA2 is 2.2 gigawatts, but we are not double counting because the other value from NO2 to DK1 is the same over here. So that's how we plot transmission capacities. And in general, I hope that these suggestions helped you for your Balmorel data analysis.